Hello, dear friends, and welcome. I'm so happy to have you here. As we begin, I'd love it if you could share in the comments where you're joining from and the time of day it is for you right now. It's always wonderful to witness people tuning in from across the world. Thank you as well to those who have already subscribed and shared their support by liking the videos. It helps more than you know. And please don't hesitate to leave your ideas or requests for future videos. Let's get started. Chapter 1. Understanding Alchemy and its Goals. Alchemy, a profound and ancient practice, invites us into a world where the boundaries of science, philosophy, and mysticism intertwine. It flourished in various cultures, particularly in the Mediterranean region during the Hellenistic period, where Greek philosophy met Egyptian wisdom. Alchemy is often defined as the art of transformation, and its most famous aspiration is the transmutation of base metals into gold. This seemingly magical quest serves as a rich metaphor for personal and spiritual transformation, a journey that resonates deeply with human desire. Imagine the exhilaration of the alchemists, those early seekers of knowledge, as they delved into the mysteries of the natural world. They sought to uncover the secrets of matter itself, believing that by understanding the nature of substances, they could unlock the potential within them. The quest for turning lead into gold was not merely about wealth. It symbolized the alchemists' desire to achieve perfection, to elevate the mundane to the extraordinary. Each alchemist believed that gold represented the pinnacle of material success and spiritual enlightenment. The historical context of alchemy is steeped in a rich tapestry of philosophical thought. The Greeks viewed the world as composed of four fundamental elements: earth, air, fire, and water. This elemental theory laid the groundwork for alchemical practices, where the manipulation of these elements was believed to yield transformative results. The philosopher Aristotle expanded on this idea, introducing the notion of a fifth element, ether, believed to fill the universe beyond the terrestrial sphere. Alchemists, inspired by these early theories, engaged in a profound exploration of matter, driven by the belief that everything in existence was interconnected. Throughout history, key figures emerged who significantly contributed to the evolution of alchemical thought. One such luminary was Hermes Trismegistus, a legendary figure often credited as the father of alchemy. The Hermetic texts attributed to him blend spiritual insights with practical knowledge. His famous dictum, "as above, so below," encapsulates the alchemical belief in the correspondence between the macrocosm of the universe and the microcosm of the individual. This profound idea invites us to reflect on the interconnectedness of all things. Another pivotal figure was Paracelsus, a Renaissance physician and alchemist who challenged the established medical practices of his time. He emphasized the importance of observation and experimentation, advocating for a more empirical approach to understanding nature. Paracelsus believed that alchemy was a means of healing, asserting that the transformation of substances could lead to the transformation of the self. His assertion that the dose makes the poison serves as a reminder of the delicate balance between creation and destruction in the natural world. As we delve deeper into the alchemical quest for transmutation, we encounter the philosophical underpinnings that guided these early practitioners. Alchemy was more than a precursor to chemistry. It was a holistic discipline that sought to harmonize the spiritual and the material. The alchemists believed that every substance contained a spirit or essence, and through purification and transformation, they could reveal its true nature. This belief in the transmutation of both matter and spirit reflects the alchemists' desire for personal growth and enlightenment. The quest for transmuting lead into gold became a symbol of the alchemists' journey toward self-realization and mastery over the physical world. Lead, often regarded as a base metal, represented the lowest state of existence, while gold embodied the highest form of material perfection. This duality resonates with the human experience, as we often find ourselves striving to elevate our own lives from the mundane to the extraordinary. The alchemists understood that the process of transformation was not a mere chemical reaction. It required dedication, patience, and a deep understanding of the natural world. One might ask, what drove these individuals to pursue such ambitious goals? The answer lies in the intrinsic human desire to explore and understand the unknown. Alchemy provided a framework for inquiry that blended science and spirituality, offering a path toward enlightenment. The alchemists often embarked on journeys of self-discovery, navigating the depths of their souls as they sought to understand the mysteries of the universe. As we reflect on the legacy of these early alchemists, we must acknowledge the fascinating intersection of their work with the emergence of modern science. While their methods may appear primitive by today's standards, the alchemists laid the groundwork for the scientific revolution. They were the first to experiment with chemical processes, documenting their findings and sharing their knowledge with others. Their relentless curiosity and quest for understanding would eventually lead to the development of chemistry as a distinct scientific discipline. The echoes of alchemical thought resonate through the ages, reminding us of the transformative power of knowledge. As we ponder the historical quest to transmute lead into gold, we are invited to consider our own journeys of transformation. What are the leaden aspects of our lives that we strive to elevate? What goal do we seek in our personal quests for meaning and purpose? The alchemists understood that the pursuit itself was as valuable as the goal, and in their work, they illuminated the path for future generations. In this exploration, we recognize that alchemy was not merely a fanciful pursuit of wealth, but a profound journey of self-discovery. It encouraged individuals to look beyond the surface of reality and seek the hidden truths that lay beneath. The alchemical process became a metaphor for personal growth, teaching us that transformation requires both introspection and a willingness to embrace change. As we delve further into the complexities of alchemical practices, we are reminded of the key figures who shaped this captivating field. From the ancient wisdom of Hermes Trismegistus to the groundbreaking insights of Paracelsus, each alchemist contributed to a rich legacy of knowledge. Their teachings continue to inspire seekers of truth, guiding them on their quests for understanding and enlightenment. In the heart of alchemical tradition lies the belief that every individual possesses the potential for transformation. The journey from lead to gold becomes a powerful metaphor for our own lives, inviting us to embrace the challenges that come our way. As we consider the historical quest to transmute lead into gold, we are encouraged to reflect on the alchemical principles that guide us: the pursuit of knowledge, the desire for personal growth, and the belief in the interconnectedness of all things. What does it mean to engage in our own alchemical practice? It may involve refining our thoughts, purifying our intentions, and embracing the transformative power of experience. As we embark on this journey, we join the ranks of those who came before us, seeking to uncover the mysteries of existence and elevate our lives from the ordinary to the extraordinary. In this light, the exploration of alchemy transcends its historical context, becoming a timeless quest for understanding and transformation. The alchemists remind us that the pursuit of knowledge is not merely an intellectual exercise, but a deeply personal journey that shapes our very being. They invite us to look beyond the surface and discover the gold that lies within us all, waiting to be revealed through the processes of inquiry, reflection, and transformation. The quest for transmuting lead into gold is not merely a physical endeavor. It embodies a profound philosophical exploration. Alchemists regarded the material world as a reflection of a deeper, spiritual reality, believing that each element held its own unique essence, a divine spark waiting to be awakened. This perspective invites us to ponder: what if the transformation of materials symbolizes our own potential for growth and renewal? Historically, the alchemical laboratory served as a sanctuary where practitioners could delve into both the physical and metaphysical realms. Within these sacred spaces, they experimented with various substances, seeking to unlock the secrets of nature. The Philosopher's Stone, a legendary creation of alchemy, was said to possess the power to turn base metals into gold and grant immortality. This mythical object represents the ultimate goal of the alchemist, the achievement of perfection and enlightenment. As we reflect on the philosophical underpinnings of alchemical practices, we encounter the works of great thinkers such as Isaac Newton, who, while celebrated for his contributions to physics, was also deeply engrossed in alchemy. Newton believed that the universe was governed by divine laws, and he sought to uncover these truths through his alchemical studies. "What I do not understand, I do not know. I am not afraid of the answers," he remarked, illustrating the relentless pursuit of knowledge that defined many alchemists. In their quest, alchemists often employed symbols and metaphors to convey complex ideas. The stages of the alchemical process, often depicted as colors, black, white, yellow, and red, represent different phases of transformation. Imagine the process beginning with the nigredo, the stage of putrefaction, where the old must die to make way for the new. This darkness is not merely despair, it is a necessary part of the journey. It invites us to confront our inner shadows, to embrace the discomfort of change, and to emerge renewed. Following the nigredo comes the albedo, or the whitening phase, which symbolizes purification. This stage is akin to the cleansing of the soul, where the alchemist sheds impurities and prepares for the next transformation. The philosopher Carl Jung drew parallels between alchemy and psychological growth, stating, "The alchemical process can serve as a guide for the individual's journey toward wholeness, where the ego and the unconscious work together." In this light, the alchemical journey becomes a mirror reflecting our own personal evolution. The next phase, the citrinitas or yellowing, represents the dawning of insight and enlightenment. Here, one begins to grasp the interconnectedness of the universe, realizing that every element and being plays a role in the grand design. This stage invites us to ask ourselves, what insights have we gained through our struggles? What wisdom can we share with others as we navigate our own transformative paths? Finally, the rubedo or reddening signifies the completion of the alchemical process. It embodies the union of opposites, the marriage of the physical and spiritual realms. The alchemist, having undergone this profound metamorphosis, emerges as a master of creation, capable of manifesting their highest potential. This completion is not an endpoint, but rather a new beginning, as the alchemist is now equipped to inspire others on their journeys. The historical figures who shaped alchemy were not mere practitioners of an ancient art. They were pioneers of thought who dared to question the established norms. They sought to bridge the gap between science and spirituality, illuminating the path for future generations. As we explore their legacies, we find that their work resonates beyond their time, reminding us that the essence of alchemy lies in the transformative power of knowledge. Consider the words of the renowned alchemist, Paracelsus. "The art of healing comes from nature, not from the physician. Therefore, the physician must start from nature, with an open mind." This perspective emphasizes the importance of curiosity and observation within the practice of alchemy, urging us to remain receptive to the wonders of the world around us. As we embark on our own quests for understanding, we are encouraged to embrace the alchemical spirit within us. The journey toward personal transformation may not always be smooth, but it is through these challenges that we uncover the gold hidden deep within our souls. The historical quest to transmute lead into gold serves as a reminder that the pursuit of knowledge and self-discovery is a timeless endeavor, one that transcends the boundaries of time and space, inviting us all to partake in the alchemical journey of life. As we reflect on the alchemical journey and the profound transformations it invites, we find ourselves standing at the threshold of a new understanding. The exploration of elements and their intricate relationships in both ancient and modern contexts reveals how these foundational components shape our reality. Just as the alchemist sought to transmute lead into gold, we now turn our attention to the scientific principles that underpin this very concept. In our next chapter, we will delve into the world of atomic theory and the periodic table, uncovering the mysteries of elements that weave the fabric of our universe. Prepare to embark on this enlightening journey where science and alchemy converge, illuminating the paths of both the physical and the philosophical. Chapter 2: The Science of Elements and Atoms. In the ancient world, alchemy was a blend of philosophy and science, a practice steeped in mystique and wonder. At its core lay a quest that captivated the minds of some of history's greatest thinkers: the transformation of lead into gold. But what did this transformation truly entail? To understand this, we must first explore the foundations of atomic theory and the nature of chemical elements. Atoms are the fundamental building blocks of matter, the tiny particles that make up everything we see around us. The concept of atoms dates back to ancient Greece, where philosophers like Democritus first proposed that matter was not infinitely divisible, but rather composed of indivisible units. However, it wasn't until the 19th century that atomic theory gained scientific traction, with figures such as John Dalton, who suggested that atoms of different elements have unique weights and combine in specific ratios to form compounds. The periodic table, a remarkable arrangement of elements, serves as a visual representation of atomic structure and properties. Each element is defined by the number of protons in its nucleus, a characteristic known as atomic number. As we glance at the periodic table, we can almost feel the rhythm of the universe, each element playing its own distinct note. For instance, hydrogen, the lightest element, has just one proton, while uranium, a heavy metal, boasts a staggering 92 protons. This organization is not arbitrary. It reflects the intricate relationships between elements, revealing patterns in their chemical behavior. Lead and gold, two elements often associated with alchemical transformation, embody contrasting properties that make their comparison compelling. Lead, with its atomic number of 82, is a heavy, dense metal known for its malleability and resistance to corrosion. Gold, on the other hand, shines with an atomic number of 79, revered for its beauty and rarity. Imagine for a moment the allure of gold, its lustrous surface capturing the light, while lead remains cloaked in a dull gray. The difference in their atomic structure lies in the arrangement of protons, neutrons, and electrons, which ultimately dictates their unique characteristics. In the realm of modern physics, the concept of transmutation, the process of changing one element into another, has evolved beyond the mystical aspirations of ancient alchemists. Scientists now understand that transmutation can occur through nuclear reactions. Imagine a particle accelerator, a magnificent machine that hurls atomic particles at incredible speeds, smashing them together and mimicking the intense conditions found in stars. This process can lead to the transformation of elements, achieving what the alchemists sought for centuries. To the alchemist, transformation was not merely a chemical process, but a spiritual journey, said a contemporary physicist, reflecting on the deeper meanings behind the quest for transmutation. In this sense, the modern understanding of transmutation intertwines science with the age-old human desire to transcend limitations and unlock the secrets of the universe. As we delve deeper into the science of elements and atoms, we can appreciate the profound beauty and complexity of the natural world. Each element has its own story, shaped by the forces of nature and the laws of physics. The periodic table is not just a list, but a narrative of creation, a testament to the intricate dance of electrons and the powerful bonds that hold matter together. When we think about the journey from lead to gold, we are reminded of the dreams and aspirations of those who came before us. The alchemists sought to understand the universe, to harness its power, and to elevate the mundane to the extraordinary. Their legacy lives on in modern science, where the pursuit of knowledge continues to inspire and enlighten. The transmutation of elements, once confined to the realm of myth and legend, has found its place in contemporary science. As we explore the atomic world, we uncover the microscopic wonders that govern our existence. Consider the possibility that what was once dreamt of in the shadows of ancient laboratories is now within our grasp, thanks to advancements in nuclear physics and our understanding of atomic structure. As we ponder the implications of these discoveries, we might ask ourselves, what does it mean to transform one element into another? Is it merely a scientific achievement, or does it reflect a deeper connection to our own desires for growth and change? In contemplating these questions, we find ourselves at the intersection of science and philosophy, where the quest for knowledge fuels our curiosity and ignites our imagination. While the historical context of alchemy focused on the transformation of lead into gold, modern science teaches us that this process is underpinned by the principles of atomic structure and nuclear reactions. The beauty of this understanding lies in its ability to bridge the gap between the mystical and the scientific, allowing us to see the universe through a lens that is both profound and enlightening. As we explore the atomic structure of lead and gold, we find that the process of transmutation is not just about changing one metal into another. It is a reflection of the fundamental forces that govern the universe. Lead, with its heavier atomic mass, presents a challenge when it comes to transformation. Yet, gold, with its unique properties and inherent stability, captivates our imagination, embodying the alchemical ideal. The concept of transmutation in modern physics invites us to consider the possibilities lying ahead. Imagine a future where the boundaries of chemistry and physics blur, opening doors to new understandings of material transformation. As we learn more about the forces that bind atoms together, we may find ourselves on the cusp of breakthroughs that could redefine our relationship with the elements that compose our world. In this dance of science and imagination, we glimpse the potential for alchemical practices to evolve and adapt, merging ancient wisdom with contemporary knowledge. The quest for transformation remains ever relevant as we strive to unravel the mysteries of the cosmos and our place within it. The journey through the science of elements and atoms is a testament to human curiosity and ambition. It reminds us that we are part of a grand narrative, one that stretches back to the dawn of civilization and continues to unfold in the present day. Each discovery brings with it a sense of wonder, urging us to look deeper into the nature of the universe and our connection to it. As we reflect on the transformation of lead to gold, both in the historical context of alchemy and the modern understanding of atomic theory, we find ourselves inspired by the possibilities that lie before us. The quest for knowledge and transformation is timeless, a thread that weaves through the fabric of human experience. In this exploration, we uncover not just the science of elements and atoms, but also the deeper significance of our pursuit. It is a journey that invites us to dream, to ponder, and to embrace the mysteries of existence. As we continue to delve into the wonders of the atomic world, we can carry forward the spirit of the alchemists, forever seeking to discover the gold hidden within the ordinary. The periodic table stands as a monumental achievement in our understanding of the elements that compose all matter. It is not merely a chart of symbols and atomic numbers. It is a reflection of the underlying principles that govern our universe. Each element, with its unique atomic structure, possesses distinct properties that influence how it interacts with others. Imagine a grand orchestra, where each element plays its part in a symphony of chemical reactions, creating the diverse materials and phenomena we observe around us. At the heart of the periodic table is atomic theory, a concept that has evolved remarkably since its inception. John Dalton, in the early 19th century, proposed that matter is composed of indivisible atoms, each with a specific weight and combining in simple ratios to form compounds. This idea has since been refined, leading to our current understanding of atoms as complex entities comprised of protons, neutrons, and electrons. The arrangement of these subatomic particles determines the element's identity and its behavior in chemical reactions. As we explore the periodic table, we can observe patterns that emerge within its structure. Elements are grouped by their chemical properties, revealing a fascinating order in the chaos of the natural world. For instance, noble gases like helium, neon, and argon reside in the far-right column, known for their reluctance to react with other elements. Their full outer electron shells grant them stability, making them nearly inert. Can you envision the tranquility of a noble gas, untouched by the frenetic energy of the chemical world around it? In contrast, the alkali metals found in the far-left column are notorious for their reactivity. Lithium, sodium, and potassium, for example, eagerly lose their outermost electron during chemical reactions, demonstrating an unquenchable thirst for stability. Observing these elements, one might recall the words of the renowned chemist Dmitri Mendeleev, who once said, "The elements, if arranged according to their atomic weights, exhibit an evident periodicity of properties." This periodicity reveals how the building blocks of matter are not random, but rather an intricate, harmonious arrangement. The comparison between lead and gold illuminates the profound differences in atomic structure and properties. Lead, with its heavier atomic mass, is characterized by a more complex arrangement of protons and neutrons in its nucleus. Gold, on the other hand, while also heavy, is prized not just for its rarity, but for its unique electronic configuration, which contributes to its lustrous appearance and resistance to tarnish. Imagine the shimmering surface of a gold ring, reflecting light and drawing the eye, a stark contrast to the dull gray of lead. Transmutation, the concept of changing one element into another, captures the imagination like few other scientific ideas. It was once the holy grail of alchemists, a dream wrapped in layers of mysticism and ambition. Today, this dream has transitioned into the realm of modern physics, where particle accelerators and nuclear reactions reveal the possibility of changing one element into another through the manipulation of atomic nuclei. This transformation, however, requires immense energy and sophisticated technology, making it a practice confined to laboratories rather than the alchemical workshops of old. As we ponder the implications of transmutation, one might ask, what does it mean for our understanding of the elements? The ability to transform lead into gold, while theoretically possible, raises questions about value and scarcity. Would gold retain its allure if it could be created at will? The very essence of what makes an element precious is intertwined with its natural occurrence and rarity. The concept of transmutation also invites us to reflect on the nature of change itself. In a universe governed by constant flux, the idea that elements can be transformed or reimagined resonates deeply. As the physicist Albert Einstein famously asserted, energy cannot be created or destroyed. It can only be changed from one form to another. This principle underpins not only the transformations of matter, but also our understanding of existence itself. As we navigate through these scientific revelations, we find ourselves at the intersection of chemistry and philosophy. The journey of exploring elements and atoms is not solely about the pursuit of knowledge, but also about the deeper questions of identity, value, and transformation. It encourages us to look beyond the surface and consider the intricate connections that bind us to the very fabric of reality. In this exploration of the atomic world, we discover not only the science of elements, but also the stories of those who dared to dream of transformation. The legacy of alchemy continues to inspire, urging us to seek the hidden gold within our quest for understanding. The dance of atoms and elements, though rooted in scientific rigor, carries with it the spirit of wonder and discovery that has defined humanity's journey through the ages. What new discoveries await us on this path of exploration? Where will our curiosity lead us next? As we stand at the crossroads of science and philosophy, the allure of transmutation beckons us to delve deeper into the past, where dreams of transforming lead into gold captivated the minds of alchemists. Their quests were not merely scientific endeavors. They were steeped in mysticism and a profound search for meaning, blending ambition with spirituality. This rich tapestry of experimentation and belief laid the groundwork for early chemistry, even as many misconceptions surrounded their successes. As we turn the page, we will explore the remarkable journeys of these historical figures, uncovering the fascinating stories of their trials and tribulations in the pursuit of the philosopher's stone, a pursuit that continues to resonate in both science and the human spirit. Chapter 3: Historical attempts to transmute lead into gold. In the realm of chemistry, the distinction between lead and gold is not merely a matter of appearance or value. It delves into the very fabric of atomic structure. Lead, a heavy metal with a dense atomic nucleus, consists of 82 protons and an intricate arrangement of neutrons and electrons. Gold, on the other hand, glimmers with its atomic number of 79. This seemingly small difference in the number of protons is pivotal, for it is the arrangement of these atomic particles that defines the identity of an element. Imagine a world where transforming one element into another was not just a fantasy, but a palpable reality. This was the aspiration of many alchemists who sought to transmute lead into gold, a goal steeped in both practical desire and mystical symbolism. The alchemical process hinged upon the manipulation of these atomic structures, an idea that would not gain scientific backing until centuries later. Throughout history, notable alchemists have captured the imagination with their experiments and theories. One such figure, Hermes Trismegistus, often regarded as the father of alchemy, blended science with mysticism. His writings suggest a deep understanding of the natural world, hinting at the relationships between elements and their transformations. Paracelsus, a Swiss physician and alchemist, believed that by understanding the connections between the heavens and the earth, one could unlock the mysteries of transmutation. He famously declared, "The art of healing comes from nature, not from the physician." His approach to alchemy was revolutionary, as he emphasized observation and experimentation, laying the groundwork for modern chemistry. Another prominent figure, Sir Isaac Newton, ventured into alchemical studies despite his renown in physics and mathematics. He believed in the possibility of transmutation and dedicated years to his alchemical pursuits. Newton's secret notebooks reveal a fascination with the mystical aspects of alchemy, intertwining his scientific inquiries with spiritual reflections. He once mused, "What we know is a drop, what we don't know is an ocean." This sentiment reflects the alchemical quest not only for material wealth, but for deeper knowledge and enlightenment. Yet the role of mysticism and spirituality in alchemy cannot be overlooked. Alchemists viewed their work as a sacred journey, a quest for transformation that transcended the physical. The Philosopher's Stone, a legendary substance believed to enable the transmutation of base metals into gold, symbolizes this spiritual dimension. It was not merely about the material gain. Rather, it represented the alchemist's inner transformation and quest for purity. As the alchemist Arnold of Villanova expressed, "The true alchemist is not one who seeks gold, but one who seeks the divine." However, misconceptions have long clouded the narrative of alchemical success stories. Many have interpreted tales of transmutation as literal successes, leading to a host of myths surrounding the practice. Historical accounts speak of alchemists who allegedly achieved the conversion of lead to gold, but these stories often lack the scientific foundation that we understand today. Instead, they can be seen as symbolic representations of the human desire to transform oneself and the world. Alchemy's legacy is profound, influencing the evolution of early chemistry. It laid the groundwork for scientific inquiry, encouraging experimentation and observation. The alchemical approach to the natural world sparked curiosity, leading to the establishment of chemistry as a distinct discipline. The transition from alchemy to chemistry was not merely an academic shift, it was a philosophical transformation. Alchemists began to seek understanding not through mystical means, but through empirical evidence. The alchemical practice, with its focus on transformation, encouraged early chemists to explore the elements and their interactions. Figures such as Robert Boyle, often referred to as the father of modern chemistry, drew from alchemical principles while advocating for a more systematic approach to experimentation. Boyle's insistence on the scientific method marked a decisive turn toward empirical observation and away from mystical interpretations of nature. As we delve into the historical attempts to transmute lead into gold, we find ourselves entwined in a narrative rich with ambition, spirituality, and the relentless pursuit of understanding. The dreams of alchemists echo through the ages, reminding us that the quest for transformation is as much about the inner journey as it is about the material world. What if we could envision the world through the eyes of these early seekers? The laboratories of ancient alchemists were filled with bubbling concoctions, the air thick with the scent of sulfur and the flicker of candlelight illuminating their arcane texts. Each experiment was a step into the unknown, a dance with the mysteries of nature. The alchemical legacy extends far beyond the laboratory. It invites us to ponder the delicate balance between material desires and spiritual aspirations. As we explore the historical attempts to transmute lead into gold, we uncover not just the story of elements, but also the enduring human spirit that seeks to transcend boundaries, both physical and metaphysical. In this exploration, we acknowledge that while the transmutation of lead into gold may have eluded the alchemists, their quest has ultimately enriched our understanding of the natural world. The allure of transformation continues to inspire scientists and dreamers alike, reminding us that the journey of discovery is often as valuable as the destination itself. As we turn our gaze towards the scientific foundation behind the dreams of these ancient alchemists, we find ourselves standing at the intersection of myth and matter. Lead and gold, both heavy metals, occupy distinct places on the periodic table, each with its own unique atomic structure. Lead, with its atomic number of 82, is known for its density and malleability, while gold, with an atomic number of 79, shines with a luster that has captivated humanity for centuries. Imagine the moment when alchemists first pondered the possibility of transforming these elements. They believed that by altering the fundamental essence of lead, they could unlock the secrets of nature and give birth to something as precious as gold. Their fervent desire to turn base metals into noble ones was not merely an economic ambition. It was a profound quest for understanding the very fabric of creation. This yearning echoed in the words of the alchemist Paracelsus, who asserted, "The art of alchemy is the art of bringing forth the concealed, the hidden, the secret that lies beneath the surface of things." Yet, what exactly is the science behind this transmutation? The answer lies in the realm of nuclear reactions. At the core of an atom, neutrons and protons form the nucleus, surrounded by electrons dancing in their orbits. Changing the number of protons in an atom's nucleus transforms one element into another. In the case of lead and gold, it requires the removal of 3 protons from the lead atom. While this process may seem straightforward in theory, the practical application demands immense energy and precision. As we reflect on the endeavors of notable alchemists, we encounter figures like Nicolas Flamel, who became synonymous with the philosopher's stone, the mythical substance believed to facilitate the transmutation of base metals into gold. Flamel's legacy transcended mere legend. He became a symbol of the alchemical pursuit. His name resonates in the annals of history, invoking thoughts of the extraordinary lengths to which these seekers of truth went, often shrouded in enigma. The role of mysticism and spirituality in alchemy cannot be understated. Alchemists viewed their work as a sacred vocation, intertwining their experiments with philosophical and spiritual insights. They believed that the transformation of materials mirrored the spiritual evolution of the self. The act of turning lead into gold was not solely about wealth. It was a metaphor for personal transmutation. As the alchemist Hermes Trismegistus famously stated, "As above, so below, as within, so without." This philosophy encapsulated the belief that mastering the natural world was intrinsically linked to achieving mastery over oneself. However, the notion of success in alchemy often led to misconceptions. Many tales of successful transmutation emerged, yet they frequently blurred the line between reality and myth. Alchemists, driven by their ambitions, sometimes claimed miraculous achievements, only to have their stories scrutinized by skeptical contemporaries. The intricate narratives surrounding these claims remind us of the human tendency to embellish, to create legends that outshine the mundane. The impact of alchemy on early chemistry is undeniable. While the alchemists may not have succeeded in their primary goal of transmuting lead into gold, their trials laid the groundwork for modern scientific inquiry. They developed early forms of laboratory equipment, such as distillation apparatus and crucibles, which are still in use today. Their meticulous documentation of experiments, even those that failed, contributed to a growing body of knowledge that would eventually flourish into the field of chemistry. As we ponder the legacies of these early pioneers, we might ask ourselves, what compels humanity to seek transformation? Is it the allure of power, the quest for understanding, or perhaps a deeper yearning for connection with the universe? The alchemists believed that through their work, they could unveil the mysteries of existence, a philosophy that resonates even in contemporary science. Consider the modern scientists who stand on the shoulders of these giants. Their experiments echo the same spirit of inquiry, though rooted in a more rigorous understanding of atomic theory. The journey from lead to gold is now a matter of nuclear physics rather than mystical incantations. Yet, the underlying ambition remains unchanged. The desire to unlock the secrets of creation, to explore the boundaries of possibility, continues to drive scientific exploration. As we delve deeper into the historical attempts to transmute lead into gold, we find that these stories are not just about metals, but rather about the human experience itself. They reflect our intrinsic need to challenge limits and redefine our understanding of the world. The alchemists' dreams, steeped in both ambition and spirituality, remind us that the quest for knowledge is often as significant as the findings themselves. In the quiet spaces of laboratories, both past and present, the echoes of those who sought to transmute lead into gold linger. Each bubbling flask and flickering candlelight serves as a testament to the relentless pursuit of discovery. The alchemists, with their hands stained by the elements, remind us that the path to enlightenment is often paved with curiosity, patience, and an unwavering spirit. Now, as we explore our own journeys of transformation, let us hold dear the lessons of those who came before us. What wisdom can we glean from their trials? What dreams can we weave from their stories? The quest for transmutation, whether of metals or of self, beckons us onward, urging us to embrace the alchemical process of life and to find beauty in our own transformations, however small they may seem. Each step forward, each question asked, is a step toward understanding the mysteries that bind us all together in this intricate tapestry of existence. As we reflect on the alchemists' relentless pursuit of transformation, we recognize that their age-old dreams have laid the groundwork for modern scientific inquiry. The quest to transmute lead into gold has evolved, shifting from mystical aspirations to the tangible realm of nuclear physics and artificial element manipulation. With the advent of advanced technologies like particle accelerators, we stand on the brink of new possibilities that challenge our understanding of matter and its limits. In the following chapter, we will delve into the foundational principles of nuclear reactions and explore how contemporary chemistry continues to push the boundaries of transmutation, revealing both the economic implications and the practical realities of this fascinating pursuit. Join us as we uncover the marvels of modern chemistry and the complex dance between ambition and scientific possibility. Chapter 4: Modern Chemistry, Limits of Transmutation. In the intricate world of chemistry, isotopes and atomic structure play pivotal roles in the fascinating phenomenon of transmutation. Isotopes are variants of elements that contain the same number of protons but differ in the number of neutrons. This subtle difference influences their stability and behavior. For instance, carbon has isotopes like carbon-12 and carbon-14, the latter being notable for its role in radiocarbon dating. These isotopes remind us that the very fabric of elements is not as fixed as it seems. Imagine a universe where the building blocks of matter are in a constant state of flux, shaped by the forces of nature. This is the essence of nuclear reactions, the processes that govern transmutation. At its core, a nuclear reaction involves changes in an atom's nucleus, which can lead to the formation of a different element. These reactions can occur spontaneously, as seen in radioactive decay, or can be induced under specific conditions, such as in particle accelerators. In our quest to artificially change elements, we harness the principles of nuclear reactions. When an unstable nucleus emits radiation, it can transform into a different element altogether. This is precisely how scientists have managed to change one element into another, including the ambitious goal of turning lead into gold. The excitement of this transformation lies not only in the change itself, but also in the immense energy that accompanies these reactions. Particle accelerators stand as monumental achievements in our scientific arsenal, enabling us to explore the depths of atomic structure and engage in transmutation. These machines propel particles at astonishing speeds, allowing for collisions that can alter atomic nuclei. It is within these controlled environments that scientists can achieve what was once thought to be the realm of myth: the ability to create new elements or isotopes from existing ones opens up a world of possibilities. The economic and practical implications of creating gold through transmutation are as profound as the science itself. Imagine a scenario where the age-old dream of alchemy could become a reality. Gold, the symbol of wealth and value, could be manufactured at will. While this sounds enchanting, the practicalities tell a different story. The process of transmuting lead into gold is costly and complex, requiring immense energy and sophisticated technology. As Nobel laureate Glenn T. Seaborg once noted, the discovery of new chemical elements is a thrilling adventure. This adventure, however, is tempered by the stark realities of economics. The energy required to create gold through nuclear processes would likely exceed the market value of the gold produced. Thus, while the science of transmutation is captivating, the economic feasibility remains a daunting barrier. Consider the implications of producing gold synthetically. What would it mean for our global economy if gold could be created in laboratories? The value of gold, deeply embedded in our cultures and economies, could potentially plummet, transforming it from a rare commodity to a commonplace substance. This possibility invokes questions about the nature of value itself. What gives gold its worth? Is it the rarity, the labor involved in mining, or simply the perception of value that resides in our collective consciousness? The journey into the world of modern chemistry reveals that while transmutation is scientifically plausible, the limits of our current technology and economic systems impose significant boundaries. The dream of transforming elements, of bending nature to our will, is a tantalizing prospect, yet it is shrouded in complexity. As we delve deeper into the science of isotopes and nuclear reactions, it becomes clear that the allure of transmutation is not merely a quest for wealth, but also a profound exploration of the very nature of matter itself. Each isotope, each nuclear reaction, reminds us of the delicate balance that holds our universe together. In this reflective space, one might ponder how far we have come from the ancient alchemists who sought to turn lead into gold. They were driven by a fusion of science and mysticism, an insatiable curiosity that continues to ignite the minds of modern chemists. Today, the tools of science are far more advanced, yet the mysteries of the atomic world still beckon us to explore further. The role of particle accelerators in this exploration cannot be overstated. These magnificent machines have opened doors to realms once deemed unreachable. With their ability to collide particles at high velocities, they allow scientists to observe and manipulate the very building blocks of matter. The sheer scale of these machines is awe-inspiring, often stretching for miles and requiring vast resources to operate. Imagine standing before a particle accelerator, where protons whirl in a circular path at near-light speed. With each collision, the potential for transformation unfolds. New isotopes are created, and elements are forged under conditions that mimic the processes occurring in stars. This is not merely experimentation. It is an art form that requires precision, patience, and a profound understanding of the fundamental laws of physics. As we consider the economic aspects of creating gold, it is essential to recognize the broader implications of such advancements. The dream of alchemy, once steeped in the shadows of mysticism, has become a tangible pursuit of scientific inquiry. Yet, the question lingers: How do we balance the allure of creating valuable materials with the ethical considerations surrounding such power? The energy costs, environmental impacts, and societal consequences of manipulating elements are all factors that weigh heavily on the conscience of the scientific community. As we push the boundaries of what is possible, we must also confront the responsibilities that accompany our discoveries. In this delicate dance of innovation and ethics, the journey of transmutation reflects not just a quest for gold, but a deeper understanding of our place within the universe. Each discovery, each breakthrough, serves as a reminder of the interconnectedness of all things. As we stand on the precipice of modern chemistry, we are invited to imagine a future where the limits of transmutation are continually redefined. The potential for creating new materials, for harnessing the power of the atomic world, beckons us to explore with wonder and caution. In this unfolding narrative, the story of isotopes, nuclear reactions, and the quest for transmutation serves as a testament to human ingenuity and curiosity. It is a journey marked by challenges and triumphs, a reflection of our enduring desire to understand and transform the world around us. As we contemplate the possibilities that lie ahead, the realm of modern chemistry invites us to dream, to explore, and to embrace the complexities of our universe. Each step forward in our understanding of atomic structure and nuclear reactions brings us closer to unlocking the secrets of transmutation, reminding us that the adventure is as much about the journey as it is about the destination. The quest for knowledge in the field of chemistry is not just about the elements we can create, but also about the wisdom we gain along the way. With each discovery, we are reminded that the limits of transmutation are not merely scientific challenges, but reflections of our aspiration to reach beyond the known and to touch the very essence of existence itself. Isotopes are the silent architects of transmutation, their existence a reminder of the delicate balance within atomic structures. Each element has a unique identity defined by its atomic number, yet isotopes reveal the hidden layers that can be manipulated. Imagine two versions of the same element, like siblings with different personalities. One may be stable, while the other is radioactive, emitting energy as it undergoes decay. This transformation, while seemingly chaotic, is governed by the precise laws of nuclear physics that dictate how elements interact and change. Within the nucleus of an atom, protons and neutrons dance in a rhythm of forces, binding together in a delicate embrace. This nuclear force is what allows for transmutation to take place. When we alter the number of protons, we fundamentally change one element into another. What might lead one to ponder is, how can we induce such a change? The answer lies in the realm of nuclear reactions, where energy is harnessed to initiate these remarkable transformations. Nuclear reactions, whether fission or fusion, form the crux of modern chemical practices aimed at transmutation. Fission, the splitting of heavy atomic nuclei, releases vast amounts of energy and can produce lighter elements as byproducts. Fusion, the merging of light nuclei, creates heavier elements, a process that fuels the stars themselves. As physicist Robert Oppenheimer once noted, in some sort of crude sense which no vulgarity, no humor, no overstatement can quite extinguish, the physicists have known sin, and this is a knowledge which they cannot lose. This acknowledgement of the duality of scientific progress challenges us to consider the implications of our endeavors. Consider the role of particle accelerators, marvels of engineering that propel subatomic particles to astonishing speeds. These machines serve as the modern alchemist's laboratory, allowing scientists to collide particles and observe the fleeting moments of transmutation. Within these collisions, new isotopes are born, some enduring for mere fractions of a second, while others can exist long enough to be studied. The energy harnessed in these experiments is immense, yet the precision required in controlling these reactions is akin to balancing on a razor's edge. Imagine standing in the presence of a particle accelerator, witnessing the collision of atoms, feeling the pulse of energy surge through the air. This is where the boundaries of chemistry blur with the realms of the cosmos, where the building blocks of the universe are reshaped. It is a breathtaking spectacle, a reminder of the power we wield and the responsibility it entails. Yet, the allure of creating gold remains a tantalizing prospect, woven into the fabric of human history. The idea of turning base metals into gold has captivated countless minds throughout the ages, from ancient alchemists to modern scientists. But the reality is far more complex. The economic and practical implications of artificially creating gold are not merely a matter of desire, but of feasibility. The cost of the nuclear reactions required to produce gold far exceeds its market value, posing the question, is it worth it? In a world where gold has long been a symbol of wealth and power, the prospect of producing it at will could disrupt economies and redefine value itself. What would happen if gold became so abundant that its rarity diminished? As the writer and philosopher Oscar Wilde mused, the only thing worse than being talked about is not being talked about. In this case, the discussions surrounding synthetic gold reflect broader societal implications, challenging our perceptions of worth and abundance. As we delve deeper into this modern chemistry narrative, the limits of transmutation reveal more than just scientific boundaries. They invite us to explore the ethical considerations intertwined with the pursuit of knowledge. What responsibilities do we carry as we venture into uncharted territories? The journey of transmutation is not just about altering elements. It is also about understanding the impact of our choices on the world around us. Each decision we make in the realm of chemistry echoes throughout nature and society, reminding us that our quest for transformation is as much a moral endeavor as it is a scientific one. As we ponder these intricate connections, we find ourselves at a crossroads where the passion for discovery meets the weight of responsibility. The dance of isotopes, the power of nuclear reactions, and the allure of gold all converge to create a narrative rich with potential and caution, urging us to forge ahead with wisdom and compassion. As we stand at this crossroads of scientific ambition and ethical contemplation, we must now turn our gaze toward the foundational principles that underpin these transformative processes. The world of nuclear physics beckons, offering deeper insights into the mechanisms of fission and fusion that drive element transformation. With each discovery, we inch closer to understanding the feasibility of producing gold and other elements through these powerful reactions. In the next chapter, we will explore the intricacies of nuclear physics, unveiling its role in reshaping our elemental landscape and examining case studies that illuminate the potential and pitfalls of this remarkable journey. Chapter 5: The Role of Nuclear Physics in Element Transformation. Nuclear physics, a field that delves into the heart of matter, reveals astonishing transformations that can occur at the atomic level. It is a realm where energy and matter intertwine, guiding us through the intricate processes that govern the universe. As we explore this fascinating discipline, we uncover how it plays a vital role in the transformation of elements, paving the way for advancements that were once confined to the realm of dreams. At its core, nuclear physics examines the behavior of atomic nuclei, the dense centers of atoms composed of protons and neutrons. This understanding has profound implications, not just for theoretical physics, but for practical applications that can alter the very fabric of materials. The significance of this field extends beyond the classroom or laboratory. It touches upon energy production, medical treatments, and even the possibility of creating new elements. Central to nuclear physics are the processes of fission and fusion. Fission, the splitting of a heavy nucleus into smaller fragments, releases an immense amount of energy. This principle is harnessed in nuclear reactors, where controlled fission reactions provide a substantial source of power. Imagine the power of a single atom being released and how that energy can illuminate entire cities or drive machinery. Fusion, on the other hand, occurs when light nuclei combine to form a heavier nucleus. This is the process that fuels the stars, including our sun. As atoms collide and merge, they create an energy release so powerful that it has captivated scientists and dreamers alike. The potential to replicate this process on Earth could revolutionize energy production, offering a clean and virtually limitless source of power. Is it not awe-inspiring to consider the raw, cosmic forces at play within our own sun, and how we might one day harness that brilliance? But what about the transmutation of elements, a concept so deeply intertwined with the alchemical pursuits of the past? Today, we stand at the precipice of possibility. The notion of producing gold through nuclear means is no longer the stuff of fables. Scientists have demonstrated that it is feasible to convert other elements into gold by altering their nuclear structure. This process, while theoretically achievable, raises questions about practicality and economics. In laboratories, modern techniques for elemental transmutation have emerged, showcasing the potential of advanced technologies like particle accelerators. These machines, capable of accelerating particles to high velocities, allow scientists to collide atoms in a controlled environment. Through these collisions, the nuclei can be manipulated, resulting in the formation of different elements. Picture a beam of particles racing through a tunnel, colliding with target atoms, transforming them into entirely new entities. One remarkable case study involves the transformation of bismuth, an element that sits just above lead in the periodic table, into gold. Researchers have successfully demonstrated that by bombarding bismuth with neutrons, they can induce a reaction that results in the formation of gold isotopes. The fleeting nature of these isotopes, however, poses a challenge. They decay rapidly, leaving behind only traces of their existence. Yet this experiment serves as a testament to the potential power of nuclear physics in redefining the elemental landscape. Another captivating example comes from the work of scientists who have experimented with the isotope of mercury. By altering its nuclear composition through neutron bombardment, they generated gold. These experiments not only underscore the transformative capabilities of nuclear reactions, but also highlight the delicate balance of precision and control required in such endeavors. As we ponder these advancements, we might ask ourselves, what does this mean for our understanding of matter? It challenges the very essence of what we consider fixed and valuable. Gold, once viewed as a cornerstone of wealth and stability, now dances on the edge of scientific manipulation. The very act of creating something so revered through sheer scientific prowess invites contemplation on the nature of value itself. The implications of these transformations extend beyond the realm of curiosity. They open doors to discussions about economic viability and ethical considerations. As we venture further into this world of nuclear physics, one might wonder how society will respond to the idea of synthesizing precious metals. Will we embrace the possibilities, or will we tread cautiously, aware of the potential consequences? In this ever-evolving landscape, nuclear physics stands as a beacon of innovation. It invites us to explore the very building blocks of our universe while reminding us of the profound interconnectedness of all things. Scientists like Ernest Rutherford and Marie Curie, pioneers in this field, have laid the groundwork for our current understanding. Their groundbreaking discoveries continue to resonate, inspiring new generations to push the boundaries of what we know. Rutherford once stated, "All science is either physics or stamp collecting." This sentiment underscores the importance of foundational principles in the quest for knowledge. As we delve into the transformative potential of nuclear physics, we recognize that the journey of discovery is as vital as the findings themselves. Let us take a moment to imagine the future of element transformation. What if we could produce not only gold, but a myriad of elements tailored for specific applications? The idea of custom-made materials, designed at the atomic level, could revolutionize industries from medicine to technology. The boundaries of what is possible continue to shift, guided by the relentless pursuit of knowledge. As we immerse ourselves in this world, it becomes clear that nuclear physics offers a profound lens through which to view the universe. It beckons us to reconsider our understanding of matter, inviting us to ponder the intricate relationships between elements and the forces that bind them. The role of nuclear physics in element transformation is not merely a scientific endeavor. It is a celebration of human curiosity, creativity, and resilience. It reflects our innate desire to explore, to push beyond the known, and to imagine a future where the impossible becomes possible. The journey through this realm is both calming and exhilarating, reminding us that within the heart of the atom lies a universe waiting to be discovered. As we continue to explore this captivating field, the stories of successful element transformations will serve as milestones, guiding us on our path. Each experiment, each breakthrough, adds to the rich narrative of our understanding, weaving together the threads of science, history, and imagination. The possibilities are as expansive as the cosmos itself, inviting us to dream, to question, and to discover. As we delve deeper into the role of nuclear physics in element transformation, we encounter modern techniques that have emerged in laboratories around the world. These methodologies are not merely the products of chance, but the result of rigorous scientific inquiry and innovative thinking. Imagine standing in a facility where massive particle accelerators hum with energy, propelling subatomic particles at astounding speeds. These accelerators create conditions akin to those found in the heart of stars, enabling scientists to observe and manipulate atomic structures in ways that were once the realm of science fiction. The processes of nuclear fission and fusion are at the core of these transformative techniques. Fission, the splitting of heavy atomic nuclei, releases energy and can yield lighter elements. Fusion, the merging of light nuclei, is the process that powers the sun and offers potential pathways for creating new elements. Each of these processes embodies the delicate balance of energy and matter, and the careful orchestration required to achieve desired outcomes. Consider the words of renowned physicist Richard Feynman, who once remarked, "The imagination of nature is far greater than the imagination of man." This sentiment resonates profoundly within the context of nuclear physics, for the universe itself has offered us the building blocks for transformation. The laboratory becomes a sacred space where this interplay between imagination and reality unfolds, allowing scientists to explore the elemental fabric of our world. Now, let us envision a laboratory where researchers are striving to produce gold through nuclear means. The allure of gold, with its intrinsic value and historical significance, has captivated humanity for millennia. But what if the creation of this precious metal were not confined to the natural processes of the earth? Picture a team of scientists, clad in white lab coats, meticulously adjusting their equipment as they prepare to bombard a target made of bismuth with neutrons. This process may seem simple, yet it is a complex orchestration of nuclear reactions that could lead to the transmutation of bismuth into gold. The feasibility of producing gold through nuclear means raises intriguing questions. Could this process be realized on a scale that is economically viable? The challenges are considerable, as the energy costs associated with nuclear reactions often outweigh the value of the gold produced. However, the pursuit has yielded greater understanding of the atomic world, unveiling the intricate mechanisms that govern elemental transformation. Within this fascinating domain, we can explore case studies that illuminate successful element transformation. One such example involves the work done at the Oak Ridge National Laboratory, where researchers have successfully transformed isotopes of mercury into gold. Their journey was fraught with challenges, yet it exemplified the spirit of scientific inquiry that propels us forward. The process required not only advanced technology, but also a deep understanding of nuclear reactions and the interplay of isotopes. As we reflect on these case studies, we might ask ourselves, what drives scientists to pursue these ambitious goals? The answer lies in the profound curiosity that motivates humanity to explore the unknown. Each experiment is a step into the uncharted territory of atomic science, where the outcomes can be as unpredictable as they are enlightening. Imagine the excitement of a researcher who, after countless trials, observes a faint glimmer of gold emerging from the reaction chamber. This moment is not simply a victory in the pursuit of material wealth. It is a testament to human perseverance and ingenuity. The thrill of discovery fuels the flames of inspiration, reminding us of our shared quest for knowledge and understanding. The transformative power of nuclear physics extends beyond the mere creation of gold. It holds the promise of new materials with unique properties that could revolutionize technology and medicine. Within the heart of nuclear research lies the potential to develop superconductors that can conduct electricity without resistance, or materials that can withstand extreme conditions. As we contemplate the implications of these advancements, let us pause to appreciate the subtle beauty of scientific progress. Each breakthrough, each moment of clarity, adds to the ever-expanding tapestry of our understanding. The stories of those who have ventured into this realm illuminate the path forward, reminding us that the journey is as important as the destination. In this grand narrative of element transformation, the interplay between nuclear physics and human creativity creates a landscape rich with possibility. The challenges may be daunting, yet the rewards are immeasurable. As we continue to explore the depths of this field, we are called to embrace the wonder that lies at the intersection of science and imagination, propelling us toward a future where the mysteries of the universe unfold before us. What new elements might we discover? What applications await to be born from our understanding of these atomic wonders? The answers await us, hidden in the intricate dance of particles and forces, inviting us to embark on this journey of discovery with open minds and eager hearts. Each exploration brings us closer to unraveling the secrets of the cosmos, one atom at a time. As we stand at the threshold of this new frontier, the excitement of scientific discovery beckons us to consider not just the potential of transforming elements, but also the implications of these breakthroughs in the real world. The question of economic viability looms large. How do the costs of nuclear transmutation stack up against traditional mining methods? With gold as a focal point, we will delve into the intricate dance of market values and fluctuations, exploring what synthetic gold could mean for our economy. The quest for knowledge leads us not only to enlightenment, but also to practical considerations that could shape our future. In the next chapter, we will uncover the financial dynamics at play, illuminating the path from atomic transformation to economic reality. Chapter 6: Economic Viability of Creating Gold. Particle accelerators, grand machines of modern physics, play a pivotal role in the extraordinary process of creating gold. These behemoths, which can stretch across miles, are designed to accelerate charged particles to astonishing speeds. When these particles collide with target atoms, they create conditions that can facilitate nuclear transmutation. The process involves bombarding a specific element, like lead, with high-energy particles, effectively altering its atomic structure and transforming it into gold. Imagine the thrill of watching these particles race along their paths, colliding with the precision of a masterful artist wielding a brush. The energy released in these collisions is immense, and the possibilities they open are tantalizing. As physicist Ernest Rutherford once quipped, all science is either physics or stamp collecting. In this case, the physics of particle accelerators takes center stage, showing us that even the most stable elements can be provoked into change under the right conditions. Yet, despite the brilliance of this technology, a critical question arises. Is it economically viable to create gold in this manner? The cost of operating a particle accelerator is staggering, typically running into millions of dollars for just a few hours of experimentation. The resources required for the acceleration process, including the energy demands and the complex machinery, add layers of expense. When comparing the costs of nuclear transmutation against traditional mining, the contrast becomes stark. Mining gold involves extracting it from the earth, a process that has its own set of costs, such as labor, equipment, and environmental impact. However, these costs, while significant, often pale in comparison to the astronomical expenses associated with creating gold through nuclear means. Mining operations can yield several grams of gold per ton of ore, while the output from particle accelerators may produce only minute quantities of gold, making it a less viable option for large-scale production. To illustrate, consider the fluctuations in the market value of gold. Gold has long been a symbol of wealth and stability, but its price can be as fickle as the winds. Economic factors, geopolitical tensions, and even shifts in currency values can send gold prices soaring or plummeting. The allure of gold is not just in its physical properties, but also in its perceived value, deeply rooted in human culture. Imagine a world where gold was artificially created and available in abundance. What would happen to its market value? Would it retain the same allure, or would it become just another element, losing its cherished status? As the economist John Maynard Keynes once remarked, the market can stay irrational longer than you can stay solvent. Synthetic gold could flood the market, leading to a sharp decline in value. The very essence of gold as a store of wealth and a hedge against inflation could be undermined. Furthermore, the potential economic consequences of synthetic gold are profound. If gold could be produced at will, the implications for global economies could be staggering. Nations that depend on gold mining could see their economies disrupted, leading to job losses and social upheaval. The allure of gold, which has historically driven exploration and conquest, could morph into a mundane reality, stripping away the mystique that surrounds this precious metal. When considering the economic landscape, it's essential to compare gold with other precious metals. Silver, platinum, and palladium also hold significant value and are subject to similar market forces. However, each metal carries its unique characteristics and uses, which influence its demand and price structure. Gold, with its historical significance and cultural resonance, often stands apart. Yet, if synthetic gold were to become a reality, would it also affect the standing of these other metals? In this imagined scenario, the market for silver or platinum might see fluctuations as investors shift their focus towards synthetic alternatives. The delicate balance of precious metal economics could be disrupted, leading to unforeseen effects on industries reliant on these materials, from electronics to jewelry. As we ponder these possibilities, we find ourselves at the intersection of science and economics. The endeavor to create gold through particle accelerators, while scientifically fascinating, raises essential questions about feasibility and consequence. The marvel of nuclear physics offers us a glimpse into the potential to redefine what we consider valuable. However, the path to synthetic gold may be fraught with challenges that extend far beyond the laboratory walls. What does it mean to hold the power of creation in our hands? With every experiment, we peel back the layers of understanding, revealing not just the nature of elements, but also the intricate web of human desire and ambition. The allure of gold may ultimately be tied to our shared history, our dreams, and our unyielding quest for meaning in the materials that surround us. As we explore the economic viability of creating gold, let us pause and reflect on the broader implications of our scientific pursuits. What role do we play in the delicate balance of supply and demand? How do our innovations shape the world around us? These questions invite us to consider not only the science of creating gold, but also the profound impact it could have on our society, our economies, and our very understanding of value itself. Particle accelerators, those monumental machines that push the boundaries of our understanding, play a critical role in the production of synthetic gold. These devices harness the energy of charged particles, propelling them to incredible speeds before directing them toward target materials. Imagine a vast cavern filled with intricate machinery, where the air hums with anticipation, and scientists, clad in lab coats, watch closely as particles collide with nuclei, prompting transformations that defy our conventional understanding of matter. In this alchemical realm of modern physics, particle accelerators can induce nuclear reactions that allow for the conversion of one element into another. This process, known as nuclear transmutation, can theoretically turn lead into gold, a dream that has echoed throughout human history. Yet, the journey from concept to reality is rife with challenges. The cost of operating these accelerators is astronomical, often running into millions of dollars per operation. Each collision, each fleeting moment of transmutation, comes at a steep price. As we delve deeper into the economic ramifications, we must ask ourselves, is the creation of gold through such means financially viable? The answer lies in a complex dance of supply, demand, and market fluctuations. Traditional gold mining has established a well-trodden path, one that involves extracting this precious metal from the Earth's crust through extensive labor and environmental impact. The global market for gold has its own rhythm, influenced by geopolitical stability, currency valuations, and even the whims of investors. Consider the cost of mining versus the cost of synthetic production. Mining operations require vast amounts of energy, labor, and resources. In contrast, while particle accelerators can produce gold in a lab setting, the sheer expense of running these facilities often eclipses the value of the gold created. The price of gold on the market fluctuates, influenced by everything from economic conditions to technological advancements. As Richard Feynman once stated, "The world is made of stories, not atoms." In this narrative of economic value, the story of gold is one of rarity and desirability, intricately woven into the fabric of human culture. Imagine a world where synthetic gold becomes commonplace. The value of gold, traditionally viewed as a safe haven during economic uncertainty, may diminish, leading to a cascading effect on its market price. Would we still regard gold with the same reverence? The implications of synthetic gold extend beyond mere economics. They touch upon our perception of value itself. If gold can be created at will, what does that mean for the gold standard, a monetary system that has shaped economies for centuries? Moreover, the potential for synthetic gold raises questions about other precious metals. Silver, platinum, and palladium share similar characteristics with gold, each possessing unique properties that make them desirable. If we can produce gold, could we not also create synthetic versions of these metals? The answer lies in the complexities of their atomic structures and the difficulty of inducing the necessary nuclear reactions. The prospect of synthetic gold offers both promise and peril. For one, if the production of gold became feasible and economically viable, it could disrupt the mining industry, leading to job losses and economic instability in regions that rely heavily on gold extraction. Furthermore, the environmental impacts of mining are significant, often resulting in deforestation, water pollution, and disruption of local ecosystems. Perhaps, in a world where we can produce gold synthetically, we could alleviate some of these environmental concerns, shifting our focus from extraction to innovation. Yet, there is also the age-old question of ethics. Is it morally sound to manipulate the building blocks of nature for our gain? As we consider the implications of synthetic gold, we must also ponder the societal impacts. How would communities reliant on gold mining adapt to a world where gold is artificially created? The potential for economic upheaval is immense, as entire industries could be rendered obsolete overnight. Let us turn our gaze to the historical context of precious metals. Gold has held a prominent place in human civilization, often seen as a symbol of wealth, power, and beauty. It has adorned crowns, filled coffers, and even served as currency. As we contemplate the creation of synthetic gold, we must ask, can we truly replicate the allure of something that has been revered for millennia? As the market value of gold fluctuates, it is essential to recognize the psychological factors that influence our relationship with this metal. The perception of scarcity plays a vital role in its value. Gold's limited availability has historically contributed to its desirability. If synthetic gold floods the market, will it alter our perception of worth? Would it become just another commodity, stripped of its mystique and allure? In the grand scheme of economics, the introduction of synthetic gold could lead to a re-evaluation of wealth itself. Would we redefine what it means to be affluent? As we ponder these questions, we find ourselves standing at the threshold of a new era, one where our understanding of value is challenged and reshaped by scientific advancements. As we continue to explore the economic viability of creating gold, let us also consider the broader implications of our scientific pursuits. The intersection of technology and market forces presents a landscape ripe with possibilities, where innovation can either uplift or disrupt. The journey ahead is filled with uncertainty, yet it is also infused with hope. A hope that our pursuit of knowledge will lead us to a deeper understanding of our place in the world and the materials we cherish. In this evolving narrative, the role of synthetic gold becomes not merely a question of economic viability, but a reflection of our collective aspirations and fears. The delicate balance of supply and demand may be tested, yet in this exploration, we uncover not only the potential for creation, but also the enduring significance of what it means to be human. As we stand on the precipice of discovery, the allure of gold remains, beckoning us to consider the implications of our quest for transformation and the legacy we leave behind. As we navigate this complex terrain, the allure of gold continues to intertwine with our ethical responsibilities and the environmental ramifications of its artificial creation. The very act of synthesizing such a revered metal prompts us to examine not only the economic implications, but also the moral dilemmas that arise from our technological capabilities. What is the environmental cost of producing gold through nuclear processes, and how might it reshape societal values in a world where abundance is no longer a barrier? With these pressing questions in mind, we turn our attention to the ethical considerations surrounding the creation of gold, delving deeper into the societal impacts and regulatory frameworks that must accompany such groundbreaking advancements. The journey ahead will challenge our perceptions and compel us to confront the responsibilities that come with innovation. Chapter 7: Ethical Considerations in Creating Gold. Creating gold from lead, while a captivating notion, brings forth a multitude of ethical considerations that ripple through the economic landscape, the environment, society, and regulatory frameworks. These implications are as intricate as the processes involved in transmutation itself. The economic implications of producing gold from lead cannot be understated. Imagine a world where gold could be created at will, where the value of an ounce of gold is no longer tethered to the arduous mining processes or the whims of supply and demand. The prospect could disrupt entire economies, leading to a devaluation of gold. What would happen to those who rely on gold mining for their livelihoods? As the renowned economist John Maynard Keynes once remarked, "The market can stay irrational longer than you can stay solvent." Such a shift in the market could lead to unforeseen consequences, creating a scenario where the very fabric of wealth is altered. Consider the potential for inequality. If only a few entities hold the knowledge and technology to produce gold, they might monopolize this newfound resource, widening the chasm between the wealthy and the impoverished. The allure of wealth could lead to a new arms race, where nations or corporations compete for supremacy in gold production. Would this lead to a more equitable distribution of resources, or simply empower those already in positions of power? As we delve deeper into the ethics of artificial element production, we must ponder the morality of creating something that has long been revered and valued. The philosopher Friedrich Nietzsche once stated, "He who fights with monsters should be careful lest he thereby become a monster." In the pursuit of creating gold, could humanity lose something vital about itself? Gold has historically been a symbol of purity and value, often intertwined with cultural narratives and human history. If we can create it at will, does it lose its significance? The ethical implications extend beyond value and economics to touch upon the very nature of existence. Should we manipulate elements and forces of nature simply because we can? The act of creating gold through nuclear processes involves not only scientific prowess, but also a profound responsibility. The question emerges, should we? Environmental implications of these nuclear processes are profound and complex. The methods by which we might create gold involve nuclear reactions, which carry significant risks. Imagine the potential fallout from an experiment gone awry, or the long-term effects of waste generated from such processes. Environmentalist Rachel Carson once noted, "The human race is challenged more than ever before to demonstrate our mastery, not over nature, but of ourselves." As we contemplate the possibility of artificial gold, we must consider the ecological footprint left behind. The processes involved in transmuting lead into gold could result in radioactive byproducts, presenting a challenge not only for containment, but also for public safety. The long-term storage of such waste poses ethical dilemmas. How do we ensure that future generations are protected from the consequences of our actions today? The legacy of our decisions must be weighed carefully, as the Earth's delicate ecosystems could bear the brunt of our scientific ambitions. Societal impacts of creating unlimited gold present a fascinating, yet troubling landscape. Imagine a world where gold is no longer a rare commodity, but a commonplace element. Would this lead to greater prosperity or a society devoid of the very value that gold once held? The alchemists' quest to turn lead into gold was often as much about spiritual transformation as it was about material gain. If gold becomes ubiquitous, does the pursuit of wealth lose its allure? How would it reshape our values as a society? In the words of cultural critic Thomas Frank, our economy is not a machine, but a living organism. The creation of unlimited gold could disrupt social structures, influencing everything from political power dynamics to personal aspirations. Would the essence of hard work and meritocracy fade away in a world where gold is no longer a symbol of achievement? As we explore regulatory frameworks for nuclear experimentation, we find ourselves at a crossroads. The delicate balance between scientific exploration and ethical responsibility is underscored by the need for stringent regulations. In the realm of nuclear physics, where the possibilities are vast, oversight becomes paramount. Who decides what experiments are permissible? Governments and scientific communities must navigate a complex web of ethical considerations. The regulatory frameworks need to evolve alongside technological advances to ensure that the pursuit of knowledge does not come at the expense of safety and morality. Historically, the lack of oversight has led to catastrophic outcomes, reminding us that the path to progress must be tread with caution. Imagine a world where every experiment involving nuclear processes is meticulously documented and evaluated for potential risks and repercussions. Such diligence could pave the way for responsible advancements in science, allowing society to benefit from innovation while safeguarding against potential dangers. The conversation surrounding the ethics of creating gold from lead is not merely academic. It is deeply intertwined with our collective future. As we stand on the brink of possibilities that once seemed relegated to the realm of myth, we must engage in thoughtful discourse about the implications of our actions. What responsibilities accompany our ability to manipulate the fundamental building blocks of the universe? As we contemplate the allure of transmutation, we must also reflect on the broader consequences of our choices. The journey towards creating gold may illuminate our path, but it is imperative that we remain vigilant stewards of the earth and of our shared humanity. In this landscape of possibilities, the ethical considerations are as layered and intricate as the atomic structures we seek to manipulate. As we continue to explore this compelling intersection of science, philosophy, and ethics, we find ourselves not only grappling with the question of what we can create, but also with the far more profound question of what we should create. To understand the broader economic implications of producing gold from lead, we must first consider the value of gold itself. This precious metal has held a significant place in human history, representing wealth, power, and stability. As we delve deeper into the potential for artificial gold production, one cannot help but wonder, what would happen to the value of gold if it became abundant? Picture a landscape where the act of creating gold no longer requires the arduous processes of mining or the environmental exploitation that accompanies it. The allure of synthetic gold lies not just in its potential abundance, but in the possibility of democratizing access to wealth. Renowned economist John Maynard Keynes once noted, "The difficulty lies not so much in developing new ideas as in escaping from old ones." This sentiment resonates as we confront the traditional views surrounding gold's value. Would society redefine wealth in a world where gold becomes an easily produced commodity. The implications extend far beyond mere economics. Should gold become so plentiful, we might witness a significant shift in global power dynamics. Nations that currently hold vast reserves of gold could find their economic influence diminished, while those with the technological capability to produce gold might ascend to new heights of prosperity. Imagine the geopolitical landscape reshaping itself in response to this newfound equality. Would nations that once relied on gold reserves for stability find themselves vulnerable as the very foundation of their economies crumbles? As we ponder these questions, we must also consider the environmental repercussions of nuclear processes used to create gold. The production of gold through nuclear transmutation involves intricate reactions that can produce toxic byproducts, raising concerns about waste management and ecological impact. The delicate balance of our ecosystems could be further strained if precautions are not taken. In the words of environmental activist Wangari Maathai, it's the little things citizens do. That's what will make the difference. My little thing is planting trees. This call to action rings true as we reflect on our responsibility to the environment. Should we venture down the path of creating gold, it is crucial we adopt sustainable practices that prioritize our planet's health. Imagine a future where the energy required for these nuclear processes is derived from renewable sources, reducing our carbon footprint and preserving the fragile ecosystems around us. By harnessing the power of solar, wind, or geothermal energy, we could mitigate the adverse effects associated with gold production. However, this vision remains contingent upon our ability to innovate responsibly, ensuring that our advancements do not come at the expense of our environment. As we explore the societal impacts of creating unlimited gold, we must also confront the psychological ramifications. The pursuit of wealth has long been a double-edged sword, often leading to greed and exploitation. Would an abundance of gold lead to a society more focused on materialism, or could it foster a new sense of community and collaboration? As philosopher Friedrich Nietzsche expressed, "He who has a why to live can bear almost anyhow." If we can articulate a purpose behind the creation of gold, perhaps to fund education, healthcare, or environmental restoration, we may find ourselves moving towards a society that values not just wealth, but the thoughtful application of that wealth. The notion of wealth distribution becomes critical as we consider the societal implications of synthetic gold. If gold can be created at will, how do we ensure that the benefits do not merely accrue to a select few? The potential for economic disparity could widen if access to the technology for producing gold is limited to affluent nations or elite corporations. This brings us to the heart of regulatory frameworks surrounding nuclear experimentation. Imagine a world where international cooperation governs the ethical production of gold, ensuring that all nations benefit equitably. Regulatory bodies could establish guidelines that not only oversee safety protocols, but also promote fair access to the technology and resources needed for gold production. Such frameworks would necessitate collaboration among scientists, policymakers, and ethicists, forming a coalition dedicated to the responsible advancement of nuclear technology. The late physicist Richard Feynman once remarked, "The first principle is that you must not fool yourself, and you are the easiest person to fool." This reminder serves as a guiding principle in our quest for ethical governance in gold production. It is essential that as we push the boundaries of what is scientifically possible, we do so with a commitment to transparency and accountability. Regulatory frameworks must be adaptive, evolving with the rapid pace of technological advancements while ensuring that ethical considerations remain at the forefront of discussions. As we contemplate the ethical landscape of creating gold from lead, we find ourselves standing at a crossroads, faced with questions that reach into the very essence of our humanity. Will we harness our newfound capabilities for the betterment of society, or will we succumb to the age-old temptations of greed and power? The journey toward understanding the implications of our actions is not merely a scientific endeavor. It is a reflection of our values, our priorities, and our vision for the future. As we continue to explore this fascinating intersection of science and ethics, let us remain vigilant in our pursuit of knowledge, ensuring that our advancements serve to uplift humanity rather than diminish it. As we stand at this pivotal intersection of ethics and innovation, we are compelled to reflect not only on the responsibilities that accompany the power of gold creation, but also on the deeper philosophical questions it raises about our collective aspirations. The age-old quest for transformation, reminiscent of alchemical traditions, invites us to reconsider the nature of perfection in both our scientific pursuits and our spiritual understandings. How do these ambitions resonate with our inherent values and the natural laws that govern our existence? In the following chapter, we will delve into the philosophical implications of transmutation, exploring how modern interpretations of the alchemist's dream can illuminate our path toward a more enlightened future. Together, let us uncover the intricate relationship between science and spirituality as we seek to understand not just what we can achieve, but what we ought to strive for. Chapter 8: Philosophical Implications of Transmutation. The quest for transmutation has always danced at the intersection of science and philosophy, inviting us to explore the deeper ethical considerations that emerge from our desire to alter the very fabric of nature. The practice of elemental transmutation, from the ancient alchemical traditions to modern scientific endeavors, poses profound questions about the moral implications of manipulating materials. Can we ethically transform one element into another, or do we risk transcending boundaries that nature has set for us? This inquiry compels us to reflect on the potential consequences of our actions, urging us to consider not only what we can do, but what we should do. Throughout history, alchemists sought perfection, believing that the transmutation of base metals into gold represented a pinnacle of achievement. This pursuit was not merely about material wealth. It embodied a quest for spiritual enlightenment and self-improvement. Alchemy was often viewed as a pathway to divine wisdom, where the transformation of substances mirrored the inner transformation of the alchemist. As the philosopher and alchemist Paracelsus stated, the art of alchemy is a path of the spirit. In striving for perfection within themselves, alchemists endeavored to align with natural laws, hoping that through their practices, they could unveil the secrets of the universe. In our modern age, the echoes of the alchemists' quest resonate in various interpretations. The scientific community has embraced the concept of transmutation through nuclear physics, yet it raises new philosophical questions. What does it mean to replicate the ancient ambitions of alchemy within the confines of a laboratory? While the methods have transformed, the desire for mastery over nature remains. Today, we ask ourselves, does the ability to transmute elements signify progress, or does it reflect a hubris that could ultimately lead to our downfall? This duality highlights the complex relationship between scientific advancement and ethical responsibility. The interplay between science and spirituality is another layer of this philosophical exploration. Alchemy sought to unify these realms, suggesting that understanding the material world was intrinsically linked to understanding the self and the cosmos. This profound connection invites us to ponder. Can the scientific pursuit of knowledge coexist with the spiritual quest for meaning? Albert Einstein once remarked, "Science without religion is lame, religion without science is blind." His words remind us that the two can inform one another, offering a holistic view of existence that acknowledges both empirical evidence and metaphysical wonder. As we delve deeper into the implications of transmutation, we must reflect on human ambition in the context of natural laws. The desire to bend nature to our will reveals a fundamental aspect of humanity, our thirst for knowledge and power. Yet, this ambition often comes with a cost. The ethical quandaries surrounding the manipulation of elements compel us to consider the potential repercussions of our actions. When we alter the natural order, are we not playing a dangerous game? The alchemists understood this, often warning of the hubris that accompanies the pursuit of transformation. Their cautionary tales serve as a reminder that, while we may seek to elevate ourselves through knowledge, we must remain vigilant of the responsibilities that accompany such power. Imagining the future of transmutation invites us to reflect on the possibilities that lie before us. What if we could harness the energy of the cosmos to create materials that could solve humanity's greatest challenges? The potential for innovation is boundless, yet it requires a balanced approach. As we stand on the precipice of scientific breakthroughs, we must consider how our ambitions align with ethical considerations. The legacy of alchemy persists in our modern quests for knowledge, urging us to seek not only the transformation of elements, but also the transformation of our understanding of our place within the universe. In this journey through the philosophical implications of transmutation, we find ourselves at a crossroads where ancient wisdom intersects with modern science. Each step we take towards understanding the essence of material transformation invites us to engage in a deeper dialogue about our role in the natural world. As we explore the boundaries of what is possible, we must also embrace the wisdom of humility, recognizing that the pursuit of knowledge is a sacred journey, one that requires us to tread carefully, with respect for the intricate web of life that surrounds us. As we ponder these reflections, let us remember the words of the alchemist Hermes Trismegistus, who proclaimed, "As above, so below." This ancient maxim calls us to consider how our actions in the physical realm resonate with the spiritual realm, reminding us that the quest for understanding is not merely a scientific endeavor, but a holistic approach to existence itself. The ethical considerations surrounding transmutation weave a complex narrative, inviting us to ponder the implications of altering the very fabric of existence. As we delve deeper into this philosophical landscape, we are compelled to ask ourselves, what responsibilities accompany the ability to transform elements? Each transformation carries weight, not just scientifically, but morally. The alchemists of old often grappled with the notion of perfection, seeking to create the philosopher's stone, a substance believed to grant the ability to transmute base metals into gold. This pursuit was not merely a quest for wealth. It was a reflection of an inner journey toward perfection itself. Imagine, if you will, the fervent dedication of figures such as Nicolas Flamel, whose name has become synonymous with the legendary stone. Flamel believed that the true alchemical process was not confined to the laboratory. It extended into the realm of the spirit and soul. "The stone is not a stone," he once said, emphasizing that the transformation of matter mirrors the transformation of the self. This intertwining of the physical and spiritual realms encapsulates the core of alchemical philosophy. In our modern world, the interpretation of the alchemist's quest has evolved, yet the foundational questions remain timeless. What does it mean to strive for perfection in an imperfect world? The pursuit of elemental transmutation can serve as a metaphor for our own aspirations. It beckons us to transform not only the substances around us, but also our understanding of ourselves and our relationships with one another and the universe. As science and spirituality intertwine, we find ourselves in a rich dialogue about human ambition. The relationship between these domains is intricate and often paradoxical. Can we truly separate the scientific from the spiritual? As we uncover the secrets of the universe, we might also uncover the deeper truths about our existence. Albert Einstein once remarked, "Science without religion is lame, religion without science is blind." This fusion of intellect and intuition invites us to explore how our scientific pursuits can be guided by ethical considerations born from spiritual insights. Reflect on the implications of this relationship. When we research and manipulate the building blocks of nature, we are engaging in a form of creation. How does that responsibility shape our actions? Are we stewards of knowledge, or are we mere exploiters of it? The alchemists believed that true mastery over the elements could only be achieved through a deep understanding of nature's laws. They recognized that the cosmos operates within a framework of balance and harmony, and to disrupt this balance could invite unforeseen consequences. Ethical considerations in elemental transmutation practices extend beyond the laboratory. They resonate within the very fabric of our societies. The potential for misuse of transmutational knowledge poses significant ethical dilemmas. Imagine a world where the ability to create gold or any valuable resource becomes commonplace. What would that mean for wealth distribution? Would it lead to greater equality or exacerbate existing disparities? The questions are as profound as they are unsettling. The alchemical tradition teaches us that the pursuit of physical transformation is inextricably linked to the pursuit of personal and societal transformation. As we stand at the threshold of scientific advancements that could allow us to manipulate elements, we must also consider what it means to be human in a world where the lines between creation and destruction can blur so easily. In this context, the reflections on human ambition become critical. Ambition can be a powerful motivator, driving us to explore the unknown and push the boundaries of our understanding. Yet, it can also lead us down paths of greed and exploitation. The alchemical wisdom reminds us to temper that ambition with a sense of purpose and responsibility. As we imagine our future, let us consider the words of the philosopher Arthur Schopenhauer, who stated, "Every man takes the limits of his own field of vision for the limits of the world." This sentiment urges us to broaden our perspectives, to see beyond our immediate desires, and to recognize our interconnectedness with all life. In our quest for transmutation, we must ask, how do we align our ambitions with the greater good? How do we ensure that our scientific pursuits serve to elevate the human experience rather than diminish it? The ethical implications of our choices echo through time, inviting us to engage in a thoughtful dialogue about the consequences of our actions. The relationship between science and spirituality, as illuminated by alchemical traditions, offers a pathway to explore these questions. By embracing the wisdom of the past, we can cultivate a more harmonious approach to our future explorations. The alchemists sought to uncover the divine secrets of nature, believing that in doing so, they could elevate their own spirits. This perspective encourages us to view scientific inquiry as a sacred endeavor, one that demands our utmost respect and mindfulness. As we continue to unravel the mysteries of transmutation, we must reflect on the natural laws that govern our universe. These laws, intricate in their design, remind us that while we may have the power to manipulate elements, we are still bound by the fundamental principles of nature. The alchemists recognized this delicate balance, often depicting their work as a sacred rite that required a deep understanding of the cosmos. Imagine the awe that must have filled their hearts when they witnessed the transformation of matter before their eyes. Each experiment was an invitation to dance with the forces of nature, a reminder that we are part of a greater whole. Their reverence for the natural world serves as a guiding principle for our own endeavors, urging us to seek harmony rather than disruption. As we explore the philosophical implications of transmutation, we must also confront the existential reflections it elicits. What does it mean to transform? Is it merely a physical act, or does it extend to our very being? The alchemical journey is as much about inner transformation as it is about outer achievement. Each step towards understanding the essence of materials can reflect a deeper quest for self-awareness and growth. As we stand on the precipice of scientific discovery, let us embrace the wisdom of the ages. The alchemists remind us that the pursuit of knowledge is not solely about the accumulation of facts. It is about the transformation of our understanding. In this way, the quest for transmutation becomes a metaphor for our own journeys through life, inviting us to explore the depths of our potential and the interconnectedness of all existence. What if we approached our scientific inquiries with the same reverence that the alchemists held for their work? How might that change the nature of our discoveries? The answers to these questions lie not only in the laboratory, but in the hearts and minds of those who seek to understand. In this ongoing exploration of transmutation, we are reminded that our ambitions must be tempered with humility and guided by an unwavering commitment to the greater good. The legacy of the alchemists persists, urging us to forge a path that respects the delicate balance of nature while seeking to uncover the profound mysteries that lie beyond. As we continue this journey, let us carry forward the wisdom of our ancestors, embracing both the light and shadow of our ambitions. As we reflect on the intricate interplay between our ambitions and the natural laws that govern transmutation, we find ourselves standing at the threshold of a new era in scientific inquiry. The reverence with which the alchemists approached their craft serves as a poignant reminder of the purpose behind our own explorations. With advancements in technology and a deeper understanding of nuclear research, the potential for groundbreaking discoveries in element transmutation is more tangible than ever. In the upcoming chapter, we will delve into these exciting possibilities, envisioning how the legacy of alchemy might evolve and reshape the future of material science. Join us as we explore the innovations on the horizon and the transformative impact they may have on our understanding of the universe. Chapter 9: Future Possibilities in Element Transmutation. The future of alchemy beckons with a sense of wonder and potential, as advances in chemistry and technology promise to reshape our understanding of elements and their transmutation. The notion of transforming one element into another is no longer confined to the realms of mystical lore. It resonates deeply within the scientific community, where researchers and innovators dream of breakthroughs that could redefine material science itself. Imagine a world where the barriers between elements are not as rigid as they seem. Recent advances in nuclear research have opened gateways to explore this notion further. The field of nuclear physics is evolving rapidly, revealing new methods for manipulating atomic structures. With sophisticated particle accelerators and advanced imaging techniques, scientists are delving deeper into the fabric of matter, examining how atomic interactions can lead to the creation of entirely new elements. This exploration is not merely theoretical. It has practical implications that could lead to remarkable breakthroughs in alchemical practices. As we stand on the precipice of this scientific revolution, we can envision a future where alchemists, now called chemists, could harness the power of nuclear reactions to create materials for a range of applications, from energy production to medicine. One could ponder the words of Marie Curie, who famously said, "Nothing in life is to be feared, it is only to be understood." Her insights resonate today, as the pursuit of knowledge in chemistry continues to illuminate the dark corners of our ignorance. With each discovery, we gain a clearer understanding of how to manipulate elements to serve humanity's needs. Imagine a future where the synthesis of rare elements is commonplace, where the alchemical ambitions of the past are realized through modern technology. Researchers are already exploring ways to transmute elements by utilizing advanced lasers and particle beams, pushing the limits of what was once thought impossible. The vision for material science is expanding. It is no longer just about the properties of existing materials, but about creating new ones that possess extraordinary capabilities. What could this mean for industries reliant on rare materials? Consider the potential to produce superconductors that operate at room temperature, revolutionizing energy transmission and storage. Or envision the synthesis of materials that could withstand extreme environments, opening new frontiers in space exploration. The possibilities unfold like petals of a flower, each revealing a new layer of potential. As we look to the horizon, speculations on the next phase of chemical exploration are rife with excitement. Researchers are beginning to investigate how quantum mechanics might play a role in element transmutation. The principles of quantum entanglement and superposition could offer insights into new ways of manipulating atomic particles, leading to innovations that may currently seem like science fiction. Albert Einstein once remarked, "Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world." This sentiment inspires scientists as they delve into uncharted territories, where imagination fuels the quest for breakthroughs in alchemy and chemistry alike. The future of element transmutation holds promise not just for the scientific community, but for society as a whole. As we contemplate these advancements, we must also consider the ethical implications of our pursuits. The desire to create new materials and transform elements carries with it a responsibility to ensure that such power is wielded wisely and for the greater good. In this journey towards understanding and potential, we may find ourselves pondering the age-old questions of purpose and responsibility in the pursuit of knowledge. The echoes of our past, where alchemists sought to transform the mundane into the extraordinary, remind us that every step forward must be accompanied by reflection. As we step into this promising future, it is essential to nurture a dialogue about not just what can be done, but what should be done. The intersection of technology, ethics, and human ambition defines the landscape of tomorrow's discoveries. What legacy do we wish to leave behind? How can we ensure that the advancements we seek benefit all of humanity, rather than a select few? The narrative of alchemy continues to evolve, intertwining science with the dreams and aspirations of those who dare to explore the unknown. Each breakthrough in element transmutation brings us closer to realizing the alchemical dreams of the past while forging a path towards an enlightened future. As we embrace this journey, let us remain mindful of the balance between ambition and caution, ensuring that our quest for transformation serves to uplift and empower. The potential for material science is vast, and the horizon is painted with the colors of possibility. In this unfolding story of alchemical transformation, we are reminded that the essence of exploration is not merely in achieving the impossible, but in the wisdom we gain along the way. Each discovery is a stepping stone toward a deeper understanding of the universe and our place within it. As we look ahead, we find ourselves on the brink of a renaissance in chemistry, where the dreams of ancient alchemists may soon become a reality. The future possibilities in element transmutation invite us to imagine, to dream, and to explore the very fabric of existence. The journey continues, beckoning us forward into the light of discovery. As we delve deeper into the future of alchemy, we find ourselves standing at the precipice of a new era in chemistry. The advancements in technology and nuclear research are like the soft whispers of a breeze, carrying the promise of transformation and renewal. Imagine a world where elements are not merely static entities, but dynamic components, waiting for the right conditions to unveil their hidden potential. This is the vision that fuels the endeavors of scientists and researchers as they explore the possibilities of manipulating the very building blocks of matter. The rapid progress in quantum physics and the increasing precision of particle accelerators have opened up avenues once thought to be the stuff of dreams. The very tools that allow us to explore the subatomic realm are becoming more refined, enabling us to approach the concept of transmutation with a level of accuracy that eluded our ancestors. As Richard Feynman once said, "The imagination of nature is far greater than the imagination of man." How true this sentiment rings as we set our sights on the infinitesimal world of particles and their interactions. Consider the possibilities presented by advanced nuclear techniques. With the advent of technologies that allow for the precise targeting of atomic nuclei, we could potentially alter the identity of elements. Picture a laboratory where a single beam of energy, finely tuned to resonate with a specific atomic structure, initiates a cascade of reactions, transforming one element into another. The possibilities for creating new materials, for energy storage, or even for medicine are profound. Could we one day create an entirely new class of materials, engineered at the atomic level to possess properties that are unimaginable today? The vision of future alchemical practices is not just about the creation of gold or precious elements, but about harnessing the power of nature to address pressing global challenges. With the rise of sustainable technologies, we can envision a world where the transmutation of elements plays a pivotal role in resource management. Imagine the potential to convert waste materials into valuable resources, reducing our ecological footprint while enriching our material wealth. The words of chemist and Nobel laureate Francis Arnold resonate here. We can't solve problems by using the same kind of thinking we used when we created them. This call to innovate inspires scientists to look beyond traditional boundaries and embrace the transformative power of alchemy. As we peer into the future of material science, we must also contemplate the ethical implications of these advancements. Each breakthrough brings with it a responsibility to wield our newfound power wisely. How can we ensure that the fruits of our labor are shared equitably? The history of science is fraught with examples of innovation that have inadvertently led to harm. Yet, as we move forward, we have the opportunity to establish frameworks that prioritize sustainability, equity, and the greater good. The insights of philosopher Albert Schweitzer guide us here. Ethics is the activity of man directed to secure the inner freedom of himself and others. This perspective serves as a reminder that our quest for transformation is deeply intertwined with our commitment to humanity. Speculations on the next phase of chemical exploration reveal a landscape rich with potential. Imagine the fusion of alchemical knowledge with artificial intelligence, as machine learning algorithms analyze vast datasets to predict and optimize chemical reactions. This synergy could lead to the discovery of novel compounds, materials, and processes that we have yet to imagine. The wisdom of the past, embodied in the alchemical texts, combined with the analytical power of modern technology, creates a fertile ground for innovation. As we venture forth, we can envision laboratories of the future that are alive with collaboration, where chemists, physicists, and biologists work side by side, united by a common goal. The walls of these spaces could reverberate with the laughter and excitement of young minds, inspired to push boundaries and explore the unknown. James Watson, co-discoverer of DNA's structure, once remarked, "I think the best scientists are always artists." The artistry of science will flourish as we embrace creativity and curiosity in our pursuit of knowledge. The implications of transmutation extend far beyond the confines of chemistry. Envision a future where new materials support advancements in energy efficiency and storage, paving the way for a sustainable future. Picture buildings that breathe, adapting their energy use based on environmental conditions, or vehicles powered by lightweight, durable materials that harness energy from their surroundings. The potential for innovation is boundless, limited only by our imagination and our willingness to embrace the unknown. As we explore these possibilities, let us not forget the spiritual essence of alchemy that has persisted through the ages. It reminds us that the quest for transformation is not solely about physical change, but also about personal growth and understanding. As we engage with the elements of our world, we come to appreciate the interconnectedness of all things. Each experiment is a reflection of our own journey, a testament to the resilience of the human spirit and the enduring quest for knowledge. In this unfolding narrative, the future of alchemy holds the promise of profound discoveries as we stand on the cusp of a new age in material science. The next chapter of our exploration beckons us forward, inviting us to embrace our role as co-creators of the universe. The whispers of the past guide us, and the wonders of the future await, shimmering just beyond the horizon. Let us move toward this light of discovery, with hearts open to the beauty of transformation and the wisdom it imparts. As we take steps into this realm of possibility, the advancements in technology and nuclear research emerge as guiding stars illuminating our path. Imagine the cutting-edge laboratories, where scientists don their white coats, navigating complex equations and intricate machinery, all in pursuit of new understandings. These spaces hum with energy, alive with the fervent hope of breakthroughs that could redefine material sciences. The advent of particle accelerators has already transformed our grasp of atomic structures, allowing us to probe deeper into the very fabric of matter. Yet, this is merely the beginning. What if we could manipulate the fundamental building blocks of the universe with unprecedented precision? The potential to create entirely new elements or compounds, ones that could revolutionize industries, lingers tantalizingly close. Renowned physicist and chemist Marie Curie once said, "Nothing in life is to be feared, it is only to be understood." This spirit of inquiry drives researchers today as they explore the profound implications of element transmutation and its myriad applications. Consider the implications of creating materials that could withstand extreme environments or those that could store energy more efficiently than ever before. Each discovery could be a key, unlocking doors to innovations we have yet to even imagine. What awaits us in this next phase of chemical exploration? The answer lies in the synergy of disciplines, where chemistry meets biology and physics intertwines with engineering. Picture a world where biocompatible materials enhance human health, where new alloys are crafted for space exploration, or even where we generate clean energy through novel chemical reactions. As we ponder these advancements, let us reflect on the words of theoretical physicist Michio Kaku. "The future is not a gift, it is an achievement." The journey of discovery requires collaboration, imagination, and resilience as we strive to harness the transformative power of science. Each step forward is a testament to our collective ambition, a reminder that the quest for knowledge is as much about creating a better world as it is about understanding the universe. Imagine standing at the precipice of this new era, where the boundaries of what is possible are continually expanding. With the potential for breakthroughs in alchemical practices, we may soon find ourselves equipped to confront some of humanity's most pressing challenges. The future of alchemy is not merely a continuation of the past. It is a vibrant, evolving narrative that calls us to engage with the elements, to explore their mysteries, and to shape our reality in profound ways. As we move forward, let us embrace this vision for the future of material science, one that is enriched by curiosity, creativity, and the shared desire to uncover the secrets of existence. The journey ahead may be filled with uncertainty, yet it is precisely in that uncertainty that the magic of possibility lies, urging us onward into the light of discovery that awaits us. As we stand on the brink of this exciting new chapter in material science, we are reminded that the quest for transformation is not merely a scientific endeavor, but a deeply woven narrative that spans centuries. The legacy of alchemy, with its blend of myth and methodology, has shaped our understanding of the elements and their potential. In reflecting on the timeless allure of transmuting lead into gold and the cultural significance of these age-old pursuits, we uncover the profound connections between past practices and present innovations. Our journey through the intricacies of element transmutation leads us to a deeper appreciation for how historical insights continue to inform and inspire modern science. Let us now delve into the enduring intrigue of alchemy, exploring the rich tapestry of its legacy and its impact on the future of scientific exploration. Chapter 10: Conclusion: The Legacy of Alchemy and Science. Throughout history, the notion of turning lead into gold has been shrouded in myth and fascination. This ancient pursuit, often viewed through the lens of alchemy, was not merely a quest for wealth, but a profound exploration of transformation, both material and spiritual. The image of a cloaked alchemist, hunched over a bubbling cauldron, is iconic, yet it often masks the deeper philosophical and scientific inquiries that drove these early practitioners. Many misconceptions linger around the idea of transmuting base metals into noble ones. The alchemical process was often seen as a literal transformation, leading people to believe that with the right formula or incantation, one could magically convert lead into gold. However, the reality was more complex. Alchemists like Paracelsus and Nicolas Flamel sought not just material wealth, but also a deeper understanding of nature's secrets. They posited that the transformation of metals was analogous to personal transformation, a metaphor for spiritual enlightenment. As Paracelsus famously stated, nature is the ultimate alchemist. When we delve into the science behind lead and gold, we find that these two elements are fundamentally different, despite their historical associations. Lead, with its heavier atomic structure, is situated far from gold in the periodic table. This means that the journey from one to the other is not just a matter of changing a few properties. Instead, it involves altering the very building blocks of matter itself. Gold's atomic structure, with its unique electron configuration, gives it its distinctive qualities. This understanding of atomic theory has transformed our appreciation of alchemy as a precursor to modern chemistry, revealing that the alchemists were not entirely misguided in their pursuits. The enduring intrigue of alchemy continues to permeate culture, resonating through literature, art, and even popular media. The archetype of the alchemist embodies humanity's eternal desire for transformation and mastery over nature. From the pages of ancient texts to the silver screen, the quest for the philosopher's stone, a legendary substance said to grant the power of transmutation, symbolizes the deepest yearnings of the human spirit. This cultural fascination speaks to our innate curiosity and the unending search for knowledge. As we reflect on how historical practices shaped modern science, we see that the alchemical foundations laid centuries ago were pivotal in the development of chemistry as a discipline. The meticulous observations and experiments conducted by these early scientists, despite their mystical interpretations, contributed to the empirical methods we now recognize as scientific inquiry. Their legacy is evident in the modern laboratory, where the spirit of experimentation persists. The alchemists' quest for understanding laid the groundwork for systematic study, moving us from the realm of philosophy and mysticism to the rigorous methodologies of contemporary science. The quest for transformation, whether of base metals into gold or of the self into something greater, remains a profound aspect of human experience. This journey reflects our desire not only for material wealth, but also for personal growth and understanding. Each step taken by those early alchemists brings us closer to recognizing that the true gold lies not in the substance itself, but in the insights gained through exploration and discovery. Imagining the vast expanse of human ambition and creativity, one might ponder, what drives this relentless quest? Is it the allure of riches, or is it something deeper, a yearning to unlock the mysteries of the universe? The answers may not be straightforward, but they resonate within each of us, beckoning us to explore and transform in our own lives. As we delve into the legacy of alchemy and science, we find a rich narrative woven through time. It tells of humanity's insatiable curiosity, its desire to understand, and the transformative power of knowledge. The alchemists may have sought to change lead into gold, but in their wake, they left a legacy of inquiry and discovery that continues to inspire. The journey from ancient alchemical practices to the modern scientific framework is a testament to the evolution of thought. Each discovery serves as a stepping stone, leading us to new frontiers in understanding matter and the universe. The alchemists, with their blend of art and science, taught us that transformation is not merely a physical process, but a journey of the mind and spirit. In this intricate tapestry of knowledge, we find that the true essence of alchemy lies in its ability to inspire wonder and curiosity. The quest for transformation, whether in the laboratory or within oneself, remains a core aspect of our existence. By embracing this legacy, we honor the alchemists who dared to dream of a world where the impossible might become possible. In contemplating the implications of their work, we are reminded of the words of Carl Jung, who saw alchemy as a symbolic path to self-realization. He suggested that through the alchemical process, individuals could achieve a state of wholeness. This perspective invites us to consider how the themes of transformation play out in our own lives, urging us to seek our own forms of gold amidst the leaden challenges we face. As we engage with these ideas, we might ask ourselves, what transformations are we seeking? What elements of our lives do we wish to transmute into something greater? The pursuit of knowledge, transformation, and understanding is a continuous journey, one that connects us to the past and guides us into the future. The legacy of alchemy and science is a treasure trove of insights waiting to be explored. Each chapter in this story reveals not just the evolution of scientific thought, but also the enduring human spirit that strives for change. As we reflect on this intricate history, we are reminded that transformation, in all its forms, is an essential part of what it means to be human. In this light, the alchemical quest becomes a mirror reflecting our own desires for growth and understanding. The stories of those who came before us serve as a reminder that the path of transformation is not just about the destination, but about the journey itself. The alchemists, with their dreams of transmutation, have left us with a profound legacy. The understanding that within every challenge lies the potential for metamorphosis. As we weave through these thoughts, let us take a moment to appreciate the beauty of this quest. The interplay of science and spirituality, the merging of the tangible and the intangible, is a dance that continues to unfold. The alchemists may have sought to turn lead into gold, but in reality, they were forging a path toward enlightenment, one that still echoes in our lives today. The exploration of transformation bridges the gap between past and present, reminding us that the quest for knowledge is a timeless endeavor. Each generation builds upon the discoveries of the last, creating a continuous thread of inquiry that weaves through the fabric of human history. This legacy is not just about the elements themselves, but also about the indomitable spirit of exploration that defines us as a species. As we ponder the enduring intrigue of alchemy, we find ourselves drawn into a narrative that transcends time and space. The desire to transform, to understand, and to elevate the ordinary into the extraordinary is a universal theme. It is a reminder that within each of us lies the potential for change and growth, waiting to be unlocked through exploration and discovery. The legacy of alchemy and science invites us to embrace our own journeys of transformation. Just as the alchemists sought to illuminate the mysteries of the universe, so too can we seek to illuminate our own paths. This quest is not merely about the end result, but about the wisdom gained along the way. The spirit of inquiry, the passion for understanding, and the courage to explore the unknown are the true gold we seek. As we reflect on these themes, we are left with a sense of wonder and possibility. The quest for transformation, in all its forms, is a reminder that each day presents us with new opportunities to grow, learn, and evolve. The legacy of alchemy continues to inspire us to seek our own transformations, honoring the ancient wisdom that reminds us of the profound connections between science, spirit, and the beauty of the journey itself. As we delve deeper into the legacy left by alchemists, we encounter a landscape rich with myths and misconceptions. The belief that one could turn lead into gold has captivated minds for centuries, often overshadowing the true essence of alchemical practice. This notion, while alluring, was frequently misunderstood. Alchemy was not merely a quest for wealth, but a profound exploration of nature and existence. As the philosopher Plato once mused, the greatest wealth is to live content with little. Imagine the alchemist in their dimly lit laboratory, surrounded by crucibles and ancient texts, conjuring not just material gold, but the spiritual transformation of the self. Each experiment was a step toward understanding the universe's hidden truths, a journey into the heart of creation itself. The myths surrounding lead and gold often mask the alchemists' true intentions. They were not simply charlatans, but pioneers who laid the groundwork for modern science, embodying the very essence of curiosity and experimentation. In examining lead and gold, we uncover key insights that reveal their elemental properties and the fascinating science behind them. Lead, with its atomic structure and heavy density, stands in stark contrast to gold, a symbol of purity and beauty. This juxtaposition invites us to consider the deeper meanings behind these elements. What does it mean to transform something dense and unyielding into something precious and revered? Historical practices, steeped in mysticism, shaped the foundations of contemporary scientific methods. The alchemists' meticulous observations and documentation of chemical reactions were pivotal in guiding future generations. It is said that Isaac Newton, one of the fathers of modern physics, was profoundly influenced by his studies in alchemy. He famously stated, "What we know is a drop, what we don't know is an ocean." This acknowledgement of the vast unknown continues to inspire scientists today as they probe the mysteries of the universe. The enduring intrigue of alchemy in culture is evident in literature, art, and philosophy. From the tales of Merlin, who wielded transformative powers, to the mystical works of Goethe, we find reflections of alchemical symbolism that resonate with our desire for transformation. These narratives remind us that the quest for knowledge is as much about the journey as it is about the destination. What drives this fascination? Is it the allure of hidden secrets waiting to be uncovered, or perhaps the hope that the impossible can be achieved? The legacy of alchemy serves as a reminder that every pursuit of knowledge, no matter how esoteric, carries the potential for profound discovery. As we contemplate the quest for transformation, we are invited to consider its implications in our own lives. The alchemists sought not just to change materials, but to awaken the spirit and intellect. Their quest transcended the physical, tapping into the very essence of human experience. Each day presents us with new opportunities for growth, much like the alchemists who labored in their sanctuaries, striving to uncover the secrets of existence. In this light, the legacy of alchemy and science becomes a beacon of hope and inspiration. It encourages us to embrace our potential for transformation, to seek understanding in the face of the unknown, and to honor the age-old pursuit of turning the ordinary into the extraordinary. As we reflect on this remarkable journey, we acknowledge the alchemists who paved the way for modern science, forever igniting the flame of curiosity within us all. In tracing the intricate path from alchemy to modern science, we uncover a rich tapestry woven with the threads of curiosity, transformation, and the relentless pursuit of knowledge. The alchemists, with their visionary insights and fervent dedication, laid the groundwork for a legacy that continues to inspire our quest for understanding. Their journey reminds us that the act of seeking, whether through the lens of science or the heart of philosophy, invites us to engage with the profound mysteries that define our existence. As we move forward, may we carry their spirit of inquiry into our own lives, embracing the potential for transformation that lies within each of us. Thus, the echoes of their labor resound in our modern endeavors, urging us to turn the ordinary into the extraordinary, just as they once dreamed.